right, so we have come to our last talk of the day. It's not over yet, but I am getting a little emotional already. And where is Yin? Oh, there you are. You're already in tomorrow, huh?
Yes, I'm in, excuse me, I'm in the future.
You, you are. It's already tomorrow where you are. I can't believe it. And anything interesting happen in the future yet?
It's a nice day in Melbourne. I'm based in Australia, so that's why I'm in the future. So good things will happen.
That's what I'm talking about. That is so cool. And so I'm going to let you take over and bring us home. This is very cool to have you here. And thank you for waking up early because I know it is a Saturday where you are, and you're waking up early on a Saturday to do this. So that shows some serious commitment, and I appreciate it. And I'll let you, I see your screen is shared here. So I'll get off the stage and let you jump right into it.
Thank you. Thank you very much. And hello, everyone. Good morning, good afternoon, or good evening, depending on where you are in the world. I'm Shin from Canva, and today I'm going to talk about using LLMs as a feature extraction method for operational optimization. A bit about myself first. I'm engineering machine learning within Canva in the content and discovery area, having been playing around with natural language processing, computer vision, and MLOps for a while now. For those who is not familiar with Canva just yet, it is an online design platform aiming for everyone to design everything, and it's how these slides are made. So LLMs, or large language models, that we have been talking about in the last 2 days, and it is the hottest kid in town right now. Lots of hypes and lots of discussions are centered around them. And what can we do with them? LLMs have revolutionized AI, breaking down entry barriers to lots of cutting edge AI applications. And we have seen many applications built on top of LLMs solely. Copywriting software, chatbot, coding assistant, pair programming buddy, tooling to understand, lengthy legal documents. The list can keep going forever. That is if you give LLMs the input, and then it will generate the desired output. However, another way to utilize LLMs, which is less talked about, is how to embed LLMs into existing technologies, whether it's to improve existing ML AI technologies or introduce ML AI capability into existing technologies. So simply put, LLMs can be used as a middle layer, bridging any upstreams and downstream tasks. And this is what we are focusing on today: LLM-based feature extraction for downstream tasks. But why do we use LLMs as a middle layer in such as building applications on top of it solely? Because we found that it can provide solutions with higher performance and accuracy at a greater velocity and at reduced cost. Sounds too good to be true? I will use 2 case studies to illustrate my point here. So one of the use cases for LLMs in Canva is for informational categorization. We have a variety of contents to form our information architecture, from design templates, media assets, to informational articles. And we would like to organize our content and information in a way that is most suitable to our information architecture with a categorization system. This categorization can be applied to various areas within Canva content and information, including our user search query, to categorize them and understand users' interests in our content. And another area is our contents page for easy internal retrieval. So let's take a look at our first case study, user search query categorization. Internally, we would like to understand what users' interests are in our content by aggregating them and then grouping them into different categories. Our content has a tree structure like this, and when we categorize user search queries, there's a series of steps to funnel these queries into different branches of our content structure. And the categorization models would be developed for each step or node of this tree structure to funnel the search queries into different category streams. For example, an intent classification is needed at the first layer to classify aggregated queries into different intent. Intent in this context is about what type of content users are searching for in our architecture. For example, some users search queries about template, some about feature, and then the others. So even though it was a straightforward text classification problem with a few classes, it still needs to go through the full model development cycle to develop this classifier in a more traditional ML route. So when LLMs came out and our intent classes increased, we thought it would be worth evaluating LLMs for this task in comparison to our existing classifier. And here are what we need to do to capture the text intent in these two approaches respectively. The first one is this single purpose text intent classifier, and it requires the full development workflow, including to collect a large amount of label data, tens of thousands of data points, and then set up the training infrastructure to train the text intent classifier, and then set up the deployment infrastructure to deploy the trained classifier. Then we can extract text intent feature at inference time. With LLM's API as text intent classifier, we only need to collect a handful of examples, under 10 examples. And then we need to design the prompt structure to output the predefined classes. And then at inference time, we could use few short learning with a few examples that we collected previously, and to extract the text intent feature at inference time. So this process is much more simplified, no training and deployment infra setup, and with a much smaller annotated data set. So in terms of development timeline, these are the timelines for the two approaches in comparison. It took about 4 weeks for us to develop this single purpose classifier, including one with data collection, exploration, and then the intent classifier training, the inference module development, and then deploy the classifier. Well, it took about a week to achieve the same task using LLM's APIs, and it significantly shortened the development process and timeline, especially for straightforward tasks on text data, such as the intent classification in our use case. And this is the overview on the operational effort for both approaches. For the single purpose intent classifier, end-to-end development time 4 weeks, and that of LLM's APIs is about 3 to 5 days. In terms of operation cost, for the single purpose intent classifier, it costs about $100 per month, while that of the LLM's APIs is roughly less than $5 per month in our case study. And the operation cost is based on the available public pricing on the vendor website respectively. And in terms of the scale and the operation of our jobs, it is a scheduled job running weekly with hundreds and thousands of input. So from an accuracy perspective, LLM's APIs is higher than the single purpose intent classifier in our case study, with only few short learning, no fine tuning involved. And here are some takeaways from this use case of us evaluating the LLMs. When to use LLM's API? It is effective on straightforward tasks on text data, and it helps fast prototyping and speed up the solution launch of the first iteration to gather more production information. It can be cost effective when the scale meets the cost saving advantages, which it does in our case studies. For prompt design, few short learning can be sufficient to show custom logic. on the text tasks instead of any fine-tuning required. And it is important to consider the standardization of the completion format, whether it is a JSON format or we structure a prompt to have the finite set of answers and only to output the answer. In terms of error mitigation, LLMs APIs do have rate limits. So to handle hitting the rate limit, throttling is needed with retry mechanism. And it's also good to have a fallback solution when possible to mitigate the negative impact of API downtime. In terms of fine-tuning, as I mentioned, feature learning is good for rapid solution release, which is in our case at the first iteration. However, when there is a scale on the data and or the custom logic, fine-tuning might be needed to maintain both performance and cost effectiveness. And we found that small training data sets are sufficient for fine-tuning, roughly about 50 to 100 data points per class in our use case, which would give us acceptable performance. And this is our first case studies to illustrate, the operational efficiency and optimization with LLMs APIs in production. Our second case studies is on the content page categorization. And we have content pages of various characteristics from pages with collection of similar templates with short form metadata text to informational articles with long form text. And we would like to group our content pages together based on their relevance and proximity in our information architecture. So essentially, we would like to group our pages together based on the semantic similarity into different topics clusters. Due to the vast difference in the text length and content information and metadata among these pages, variations of further text feature extractions are necessary using pre-LLM natural language techniques, such as keyword extraction with a keyword extraction specific Python library, text summarization with existing model architecture or libraries to do so, and then the key point or dot point extraction to further distill this key information from these different variations of the pages into the similar text forms, and then we can convert the text of similar forms into the embedding space before we categorizing and grouping relevant pages together using these features. And this feature extraction requires different methods and frameworks and libraries, as I mentioned, which are pretty scattered rather than a one methods to go to and do everything for us. So when LLMs came out and the variations of our content pages increased, we thought it would be worth evaluating LLMs for this task and see if it can simplify the feature extraction step all at once. So we have experimented with different feature extraction methods with the combination of open source embeddings, such as the sentence transformers, BERT embeddings, or the LLMs embeddings. And these are the metrics for our content page categorization. Using different text and feature extraction methods, we define 3 metrics to evaluate the performance of this task. Balance, to indicate how even the pages are grouped across all the pages in scope, to see how balanced they are instead of a concentrated set of pages in all groups. Completion indicate the percentage of these pages in scope are grouped into relevant topics or clusters instead of being left out as outliers. And coherence is the way that the pages grouped together is coherent and sensible instead of non-related pages being grouped together. So we experiment all these different methods and combinations with the embeddings, and it turns out that LLM embeddings on plain page text without any text feature transformation gives the best outcome. It achieves the most balanced grouping, and it grouped 89% of the pages in the relevant categories, which is the highest among all the other methods. And you can see here also it achieves the highest coherence score among other feature extraction methods. And this is also the overview on the operational effort for both approaches. So for the single purpose methods plus open embeddings, the end-to-end development time is about 2 weeks. That's only for the feature extraction step, while that of LLMs embeddings is about 3 to 5 days. The operation cost for the pre-LLM method is about $3 per month, while it's part of the training step. That's the training cost, and that of the LLMs embeddings would be about 1/3 of that. And as we discussed in the previous slides, that the metrics for this task actually LLMs embeddings can achieve the highest scores for all the metrics defined for this task. So in these case studies, we also have a few takeaway learnings using LLMs as the feature extraction. In terms of feature variations, since it's one foundational model to perform various text feature transformation and extraction, such as keyword extraction, text summarization, a significantly simplified development process. On the other hand, the text feature extraction can be non-deterministic, depends on your configuration and settings. So the meaning that the output of the LLMs can be slightly different every time even though you put the same input in. Therefore, the suitability of which depends on use cases. And obviously, in our use case, this is not a problem. And in terms of embeddings, we found that LLM embeddings appear to represent the text input better than other available text embeddings. And the format and the length of the text inputs doesn't seem to affect the semantics understanding much in the LLM embedding space. In the future, we will also consider open source LLMs, which can be utilized for text embeddings and other feature extraction tasks when suited, and potentially lower the cost even further at scale in production. So these are the 2 case studies where we evaluated LLMs as a feature extraction method to understand its operational performance better. And we concluded that LLMs outperform other methods on the natural language tasks and text feature transformation and extraction tasks in our case studies, with minimum processing and logic required. The utilization of LLM's API in our use cases also simplifies the development process and reduces the development effort and significantly shortens the timeline as well. The cost of LLM's API is model dependent. However, in our use cases, it appears to have lower operational costs for both model training and inference. And I hope, and with the above, we found that LLMs based on feature extraction can be operationally optimal, especially for rapid solution productionization. And I hope these 2 case studies illustrate, this point enough for you to give it a go and see whether it actually helped your development process. And that's it. Thank you. And I hope you enjoyed my talk.
Oh, so good. What a closing. You did not disappoint. And there are some awesome questions coming through here in the chat, which is how you know it is good, because if we haven't even finished and I didn't even have to ask for questions and they already are coming through, whew,
Excellent.
means there's quality here. So there's an awesome question about which API was used when you were doing these LLM embeddings.
Yeah. In terms of the LLM embeddings, we use the OpenAI API, and with the text the V2 model, which appears to be the most performant and the most cost effective.
Nice, nice. So, what do you think about the use case or use cases where processing millions of samples daily is a requirement? Any thoughts on how you would go about that kind of workload?
Yeah, yeah. So I guess for millions of inputs, that's at scale. And in our case, there's two ways to go about it. In our case is that when we do the users search queries categorization, what we did to kind of like minimize or like reduce the actual volume of the data is to do the aggregation if possible. In our case, again, our search queries are also at the magnitude of like millions per day. However, we are able to kind of like do the aggregation and do some of like the pre-processing to do a little bit of heavy lifting work to kind of like group them, aggregate them together to reduce the volume, and then use LLMs to do downstream tasks. If that's possible to reduce the volume, and LLMs still provide you a simplified methods to do the processing, that's one way to go. On the other hand, if that's not a viable approach, then I will probably look into, as I mentioned in the learnings and the second use case, probably would look into the open source LLMs and see how to utilize it within your infrastructure, and hopefully you could set up your open source LLMs, and then you have an in-house API, and that hopefully can provide you with the LLM embeddings source, and that could also be utilized within your organization. That way, with like a little bit more upfront setup, and hopefully down the track it would pay off without the API cost with the external API.
Nice.
Have I answered
So,
the question?
there's some awesome questions coming through here, and that definitely answered the question. I'm wondering about, all right, so Mempreet is asking, did you also try Cohere embeddings? Was there multilingual content in your test?
Yeah. So our focus is on the English only. So this is like in the use case. And the I did try it with like multi different languages. Probably not super into the in the embeddings. However, when I try the the multi language, essentially is to only operate in the text space, so that I could input text and now get the different the output in the relevant languages, and then I use the open source embeddings to convert the the text in the in other languages into the embeddings. So I did explore that way as the initial experiment, but we found that the LLM's embeddings on plain text is the way to go, and our kind of like scope is more on the English side. So I did not thoroughly experimented with the multi-language in terms of the embeddings, but for the text, more like the translation or like the localization of only in the text space, I think that still works okay for us in my exploration.
So I don't think I told you, but all of the material and all of the creative that we have for this conference, and specifically your virtual background, all made with Canva. So
Beautiful.
yeah, I have to
I'm
say
very
that
glad
right
to hear.
now. Yeah, it's super awesome. We love it. And now I got a hard question for you coming through in the chat, and you may or may not want to answer this depending on how confident you're feeling with the PR team. So Canva had a major data breach a few years back. Has that influenced the way that you work or your current direction in any way?
Well, I believe the bleach that we mentioned is probably in a few years back, or probably
Mm.
more than 4 or 5 years now. And I think we definitely, definitely experience like different things, and then we learn from it, and that definitely especially from a security as a security perspective, we definitely learn a lot from them, and since then we definitely strengthen our um from an organizational and also like the technical perspective, we will definitely strengthen the area around security. And I believe that since then there's no break after that. So definitely it's definitely a learning experience from us, and we learned a lot from it. And I think we kind of handle and did well since then.
For sure. Awesome. So this has been super fun, and I thank you so much for coming on here and talking to us and just sharing what you've been up to at Canva. As I mentioned, we're huge fans. The small team that we have, we love using Canva for everything design, and it's almost gotten to the point where I don't even know why I'm paying for Adobe anymore. Don't quote me on that. but
Canva's the way
but
to go.
every month I'm like, do
Right.
I need my Photoshop subscription? Do I need my Adobe Cloud subscription? And yeah, I think there are so many pluses. It's just so easy to use Canva, and that's a testament for what you all are doing and how you are making it intuitive. And I can tell by the way that you're thinking about how to use LLMs, you're really thinking about how you can make the AI aspect of Canva also intuitive.
Definitely, yeah, that's definitely, and I'm glad that Canva is being adopted with the community, and it's easy to use and design everything for everyone, and I'm glad that our mission is on the right track.
Yes. Yes. All right. Well, awesome. Thank you for coming. Thank you for presenting. This has been amazing. You have a beautiful new day to begin, and I have a beautiful night to go to sleep.
Thank you for
so,
having me. It's been fun.
uh,
It's been great. Thank you so much.
likewise. I'll see you later. And with that, I'm going to close it out.